Hey guys, so today I wanted to share with you how I came up with a method for building a steel and cedar fence using stainless steel C-channels. Now, I can't say for certain that I'm the only person that's ever done this, but I've searched all over the internet and I can't find examples of other people having done it this way. So it's either a really inventive and unique idea, or people know that it's not going to work in the long run and one of these days my fence is just going to collapse. But the fence came out real nicely, and given the method is at least unique, I wanted to take the opportunity to share it with other people in case you too might want to build a fence using these. Okay, so unfortunately when I was building the fence, I wasn't really planning to make a video like this about it. It was only after I spoke with some of my friends in construction who said, hey, that's a pretty neat idea, you should share that with other people. So anyways, I don't have a lot of video that kind of goes through and illustrates exactly how I did this. I did, of course, shoot random videos and photos just for friends and family. So what I'm going to do is just pull from those the best that I can to try to explain how this works. The rest of it I'll just have to tell in this kind of format, so I apologize in advance if the video seems a little bit disjointed, but I'll do the best that I can. So the general problem when working with wood and steel fences is how do you affix the wood onto the steel? And it's not nearly as obvious as it might seem at first. There's a lot of different ways to do this, but one of the more common ways is to use angle iron. And I've got a piece of it right here. This is probably a smaller piece than people would use for the type of fence that I've constructed, but it illustrates the point nevertheless. So what you would do is you would have your tubing, this is a small piece of it of course, and this is the 2-inch, the same size that I used for the fence that I built. And what you do is effectively run this on the inside track of the vertical posts. So you'd have a piece here, you'd have a similar piece on this side. And then what you can do with the angle iron, again, it would probably come out a little bit further than this little piece that I have. It's just scrap. But you could use this to affix some type of backing wood to it, being 2x4s or whatever the case may be. The problem with this is, and it does work just fine, but the problem is that I've got 43 sections to my fence, and each one of them is roughly 6 feet tall. So if I needed to have 2 of these per section, you're looking at 43 sections times 2, that's 86 pieces of angle iron, and that excludes all the gates and everything else that I've got. So then 86 pieces times 6 feet, you're looking at about 500 feet of angle iron that you'd have to purchase in order to make this work. So it's pretty expensive, it requires a lot of steel, it requires a lot of welding, so I didn't really want to go with this option. So I did some research and I found that there is this company that exists, and what they've done is come up with a proprietary solution to building these types of fences. Essentially what they did was they took a type of tubing, I'm not sure what size they used, and they effectively created some type of steel channel. And what they did was they affixed the two of these things together. So from the inside you effectively have this little slot channel. When you put the post in the ground on this side and you put the other one on this side, what you essentially have are these channels where the wood can slide directly in between the slots. And that's how you build it. You put the fence together, you lay all the posts, now you've got all these channels, they send you the faux wood, and you start inserting the pieces of wood between the channels. So it's an elegant solution that they came up with, no doubt about that. But it's very expensive, it is proprietary, and the posts need to be exactly perfect in the ground in order for the fabricated wood to fit in between the slots properly. So I didn't think that this was a method that I could use. Of course, at the same time, it did make me wonder, is there some sort of way that I could use channels to effectively affix the wood to the steel? Because that's the problem I'm trying to solve. And it turns out that there was a solution that I came up with, and again, that was using these C-channels. So once I realized that there was probably a way that I could use these channels, I still had to figure out how to do it. So I went up to Home Depot and I discovered that they sell these stainless steel C-channels, and I started playing around with them. So I realized that a standard pressure treated 1x4 would fit perfectly into the channel slot. But still, I figured that I could probably do better than the channels that they were selling at Home Depot. So I went to my local metal supply store and found a bunch of different channels that they sold. Now, they all fit my idea perfectly, but the only ones that I could find with straight ends were made from aluminum, and I knew that I would struggle to affix aluminum to steel. So that just wasn't going to work. The steel supply stores did have a type of C-channel available. Unfortunately, the ones that they sold were made by heating a block of steel and then using a press to forge out the channel. The result is that the channel winds up being angled, which prevents the 1x4 from fitting into place. You can see what that looks like in the video here. This is a little different from the stainless steel C-channels, where they start with a single piece of steel and then bend the two edges just to form the channel. Again, you can see how that works in the video. It fits perfectly into place. So anyways, after all of that, and really just wanting to get my fence finished, I decided that the original C-channels that I found at Home Depot would probably work for what I was going for. So I cut one of them to size and clamped it onto the steel tubing. Then I made sure all of the dimensions would still allow for the cedar to properly fit. So I installed a piece of the 1x4 and clamped a board of cedar onto it just to see what it looked like. It fit perfectly. Once I could prove that the idea worked, we tacked two of the C-channels into place. Then I reinserted the 1x4 just to make sure it still fit smoothly once the C-channels were properly tacked into place. And it seemed that it worked just fine. So that's when I concluded that this was probably going to work for the entire fence. So it turns out that Home Depot doesn't actually stock very many C-channels at any given time. Now this one's already been cut to the 3.5 inches like I was saying, but they sell them in 36-inch pieces, and you might find 5, 6, maybe 7 in the bucket at any given time. So I needed 30 of them. So I actually spent an entire day driving around the greater Austin area and going to all the different Home Depots to buy out as many of them as I could. So once I had them, I built a jig out of wood and immediately got to cutting all of the C-channels with my grinder. So the jig was designed so that I could slide the steel into a wooden frame. It would hold it in place, and a cut line was exposed right at the right measurement, so I knew exactly where to use the grinder. Now it took me about 3 hours or so to cut just over 300 individual pieces, and when I was done, I filled all of them into a Homer work bucket, and that was it. Okay, so the purpose of this video isn't really to show how to build a fence, but really just to talk about how to use this method for backing boards on a steel and cedar fence. That said, I will show a really quick slideshow just of how the cedar actually got affixed to the backing boards. It was a fun process. My neighbors helped me a little bit. It took about 2 days to get all of the boards up, and I thought that was pretty good given that it's about 340 linear feet of fencing. So there it is. So if you have a general idea of how to construct a fence, I don't need to go into all of the details, but the one thing that I do want to talk about is how I actually managed to cut all of the 1x4s out. This was by far the most labor-intensive process of the entire job. The reason is pretty simple. It's very difficult to measure the distance between the two inner parts of the C-channel, and it's just because they're not very wide, 3/4 of an inch, and of course they've got a 1/8 inch lip at the top and at the bottom. So really what you need to measure is the inner distance between those lips. But what you can do, and what I did, was just to measure the distance between the top tube and the bottom tube. From there you can subtract 1/4 of an inch. Now, because of the fact that I needed this to be so precise, you really want to make sure that the 1x4s get locked into the C-channels very tightly. I wouldn't cut off the entire 1/4 of an inch. Instead, I would cut somewhere around that. Once I was done with that, I would fit the 1x4 up to the C-channel and see how it measured up. From there, I could really just kind of eyeball it. And when I was making the adjustment cuts, we're talking extremely small cuts, sometimes not even the width of the miter saw blade that I was using. So this took a really long time. I had to do several hundred 1x4s across the entire fence. I estimated it probably took me over 600 cuts to do this because I really wanted them to be perfect. So I would put it up next to it, see how it fit, adjust it, see how it fit, adjust it. A lot of times I get lucky the first shot, sometimes the second. but I could always do it by the third or at worst case fourth cut. They shouldn't slide in loosely, but you also shouldn't take a hammer to them. It should be somewhere in between that. It should be where you can fit the 1x4 into the C-channel and just give it a light tap, and it should fall into place pretty nicely. If you've got it like that, they're gonna fit perfectly. They're not gonna move, and naturally what's gonna happen is the wood is gonna expand ever so slightly, which is just gonna give them that much more tension inside of the C-channel. So here you can see what these look like. This is from the backside of the fence, my neighbor's side. So the little 3.5-inch steel C-channels are welded here. We've got 3 of them per section. So you've got 1 on either side and then 1 in the middle. Here's the other side of the same fence section. And then of course they just appear at the bottom also. So you've got 1 at the top, 1 at the bottom. The 1x4 sits between that. And effectively that's what creates the structure that then allows you to affix the cedar to the other side of it. I think one of the things that's kind of nice about it is when you see the backing boards themselves, you don't really notice the C-channels. They're pretty small. They only come down 1/2 inch, so it really just kind of looks like you've got these 3 backing boards affixed onto the fence somehow. And I think that's actually kind of a neat illusion. It's one of the reasons that I like this method. So there is one obvious improvement that would come with this fence, and that's if you could find a C-channel that had a taller lip. So a while back I had filmed a video for a friend of mine just explaining how I would like to pursue that in the future. So I'm just going to go ahead and run that clip just so you get an idea of what I'm talking about and what my thoughts were on that. So the only thing I would have really liked to do a little bit differently is if I could have found C-channels that extended down further. So basically you've got a 1/2 inch lip here, same thing on the other side. And of course, the further this comes down, then the more wood that you have locked into the channel itself. They do make them, it's just some specialty companies that I had to find online, and I wasn't really sure how it would work. I didn't want to wait to have them shipped. And then of course I'd have to get one of them tested and then ultimately put in another order for the larger bits that I needed. So anyways, I went ahead and used these. I've tested them. They seem to work really well. So long as the 1x4 is really cut to size, I don't think there's a problem with it. Ultimately, it's got 1 inch that it's held in with between the top and the bottom. Okay, also regarding this, I would be remiss if I didn't say something about safety. I generally try to use as many safety protocols as possible when I'm doing construction, but I've also been doing construction for a very long time, and I know how people have a tendency to forego certain things. You just don't think you need to. I totally understand this. I'm not judging. So when you're working with a grinder in particular, when you're cutting metal, it's extremely important that you wear some type of face shield. I would strongly encourage people to wear a mask as well, and I would strongly encourage long sleeves and gloves. You've got flying shards of effectively metal plasma that are flying towards you. They do hurt. If you were to get them in your eyes, it's certainly going to cause some permanent damage. But the reason I want to bring it up in the case of this video is because normally when I'm working with a grinder, I'm only going to be cutting a few pieces of metal. But if you follow this method and you actually cut as many of the C-channels as I did, this becomes somewhat of an industrialized process. So as I mentioned, I did something like 300 cuts. I think it was actually about 320. And I didn't even realize I had my facial shield on. I was listening to a podcast, and I was probably about an hour into it when I looked down and realized that my entire shirt had just been burnt off of me. There were little metal pieces that had connected together, and really half of my chest, or my stomach anyways, was just a solid piece of steel at that point. Also, when you see the amount of dust that was created from this, really good idea to wear a breather. I was not wearing one. I regret that. That was foolish. But of course, I do have the full face mask on. Hearing protection is extremely important. I'll put a link in the description to the specific one I got off Amazon, really cheap. Definitely wear that. I would wear a mask as well. Certainly wear gloves, and I would suggest wearing an apron as well, or something to protect your clothing from this, because getting that much steel dust off of you is a nightmare. It gets everywhere, and it will burn right through any fabric that you're wearing. So safety is extremely important when working with these tools, especially in the capacity in which you're going to need to be operating them. So I would definitely take that into consideration if you're going to try this method. So the one real limitation I found to using this system just has to do with the height of the fence. Basically, once the fence exceeds about 6 feet tall, the 1x4 backing board loses the rigidity that's necessary to prevent it from being able to bow. So this should be pretty obvious. If you're holding, say, a foot-long piece of a 1x4, you can't bend it. It's just too short, so it's extremely rigid. As that grows in length, it becomes very bendy, very flexible. So if you exceed roughly 6 feet, I'm not sure exactly where it is, the system just doesn't work any longer. So I'd recorded a video a while back just illustrating what happens when the height of the fence exceeds the rigid capacity of the backing 1x4. So you'll get a pretty good idea of what it looks like if you exceed that particular height. I'm sure you can see that the fence looks normal, going all the way down it. However, this particular one right here, what you can see is that the fence is buckling out ever so slightly. So you can kind of see why it buckles out, but it's not that hard to understand, right? If you were to take a 1x4 that's just, say, a foot long, and you hold it, it's going to be extremely rigid. They sell them in, say, 20-foot pieces, though. If you take a 20-foot piece of a 1x4 and you hold it out, it's going to have a huge arcing to it. So I think basically what's happened here, when you've got this, I don't know, whatever this is, 6.5, 7 feet of a backing board, it's just too long for it. But yeah, I mean, I think overall the system works really well. It's been super stable. It's survived the big snowstorm that we had. It's survived a bunch of storms, some heavy wind. And it's been going for 5 or 6 months now. And I don't really notice any problems with it. So I would say it's a pretty successful method for doing a fence. I think it's cheaper. I think it's easier. And personally, I think it looks a little bit nicer. I like the idea that you don't see the excess metal that's actually holding the cedar together. So I think that's a feature to it, and I would recommend it to people. Okay, so that's it. So hopefully you found this video interesting, if not extremely useful, for using these C-channels to build a steel and cedar fence. I'll go ahead and put links to all the products that I used in the description. And if you have any questions about it, please feel free to comment or shoot me an email, whatever else. I'd be more than happy to provide any answers that I can about how the system works and perhaps how you can improve it.